Okay, so today I'm going to work in this Holt physics book, chapter 6, number 24. Okay, a 65 kilogram ice skater moving to the right with a velocity of 2.5 meters per second throws a 0.15 kilogram snowball to the right with a velocity of 32 meters per second relative to the ground. Part A. What is the velocity of the ice skater after throwing the snowball? Okay, so what we have here is we have a collision, believe it or not. We have an ice skater who's just kind of skating around, and he has some momentum, and he throws a snowball, which is where the collision is. And the total momentum after the final momentum has to equal the initial momentum, which we already know because of conservation of momentum. But what that means in this scenario is that the initial momentum of the skater with the snowball, because we have to assume that he has the snowball because he can't just throw it without holding it first. So his momentum equals, after he throws it, equals the sum of his individual momentum plus the momentum of the snowball. So that's what we have to do. So first, we have to find that momentum. So we start by saying initial momentum equals final momentum. Pi equals Pf, which we know always is true. Okay, and of course in this problem we disregard friction like we always do. Okay, so we have initial momentum equals final momentum. Well, what's initial momentum? Well, momentum is mass times velocity. And initial momentum would be the momentum before the collision. And so the mass before the collision is the mass of the skater plus the mass of the snowball. The velocity before the collision is, well, the velocity before the collision. Okay, and so we have mass of the skater, which I will represent by ms, plus the mass of the snowball, which I will represent by msn, times the initial velocity. So that's our initial momentum. Now what's our final momentum? Well, again, momentum is mass times velocity. Well, what's a mass and what's velocity? Well, since the objects they're not touching, we have to treat them as two separate entities. And so we have the mass of the skater and the velocity of the skater, so he has momentum, and the snowball has momentum. And so we have ms times final velocity of the skater. So we have the final momentum of the skater, which is ms vsf, plus mass of the snowball times the final velocity of the snowball. So that's our final momentum. It's written, it looks like this. Okay, I hope you can read that. So, what do we want? What do we want? We want the velocity of the ice skater. And so, I just solve for it, like algebraically, and then just plug everything in. It's easier that way, I find. Okay, and so, velocity of the ice skater, that's VSF. And so, first, we rewrite the left side of the equation. ms plus msn times vi, that's just the left side written again, minus mass of the snowball times the final velocity of the snowball equals mass of the skater times the final velocity of the skater. So now we're here. Okay. And now we just divide by the mass of the skater on both sides, because that will isolate the final velocity of the skater, which is what we want. Okay, so we have mass of the skater plus the mass of the snowball, in parentheses, times the initial velocity, minus the mass of the snowball. Right, let me erase that, I messed that up. Mass of the snowball times the final velocity of the snowball, all divided by the mass of the skater. Let me make this more readable for you. Okay, and that equals the final velocity of the skater. So I know it's a lot of velocity, but that's what we have so far. And now we just really just plug it all in. So we have the final velocity of the skater, VSF, equals mass of the skater, 65, plus the mass of the snowball, 0.15, times their initial velocity, 2.5. minus the mass of the snowball, 0.15, times the final velocity of the snowball, which is 32. Whoa, that's really fast. All divided by the mass of the skater, which is 65. And so that comes out to be 2.43 meters per second, of course. So that's part A. Fun, right? That wasn't so bad. All right, now, part B. B says, a second skater initially at rest with a mass of 60 kilograms catches the snowball. So it sounds like we're going to have another collision. What is the velocity of the second skater after catching the snowball in a perfectly inelastic collision? Okay, well. Whew. Okay, so we have another collision, and apparently it's inelastic, is what they say. So that means that when we have two systems becoming one. Earlier we had one becoming two, now we have two becoming one. So we have, this is a different skater, okay? No, he has the same mass. So, mass of the skater times the velocity of the skater initially, plus the mass of the snowball times the initial velocity of the snowball, equals mass of the skater plus the mass of the snowball times some final velocity, because that's the equation for an inelastic collision. I keep messing this up when I write it, so I'm erasing it. I'm still getting it wrong. Okay, we're good. So what we're looking for? We're looking for the velocity of the second skater. Okay, so in other words, VF. Alright, because what we have now is we have this. Okay, so that's an inelastic collision, right? And so, we're just going to solve for final velocity. So we just divide everything by the mass of the snowball plus the mass of the skater, because that would isolate our variable. So, VF equals mass of the skater times the initial velocity of the skater plus the mass of the snowball times the initial velocity of the snowball, all divided by mass of the skater plus mass of the snowball. Looks like this. Oakley dokley. Now, we just plug everything in. So VF equals mass of the skater is again 60 times the initial velocity of the skater is 0 plus mass of the snowball is still 0.15 times the initial velocity of the snowball. Well, the initial velocity of the snowball would just be 32, the speed at which the first guy threw it. The first guy apparently has the exact same mass. Okay, so that divided by the sum of the two masses. So 60 plus 0.15. So it looks like this. I really hope you can read that. So VF equals, so let's see what that turns out to be. (0.0798), which if we're doing sig figs is equal to, we have 3 sig figs. So, no, that's correct. That's correct. It's 3 sig figs. Oh yeah, my mistake earlier. I just realized that they don't have the same mass. But don't worry, I did the math right. Just the first guy's mass is 65, the second one's mass is 60. So cool, yeah. So the final velocity is 0.0798 meters per second. Well, that's that problem.